Alright, so we're in video number 2. Try and go quick here. Obviously we were chatting about being on this bus and that if certain students tried throwing gum at the speeding car, zipping past them, going much faster than the bus, they may find themselves having a tough time hitting the target. And so it would make sense to go and draw if they're going to throw it right at the car, if they're going to draw it like this, they're going to throw it and it's just going to miss the car. So now all of a sudden we can go and add a few more of these arrows to show how the air pattern would behave. So again, we were trying to throw an object at the sports car, but because it's moving so fast, we couldn't hit it, and so we miss it. And so you get this kind of air patterns like this. Now, say we wanted to go and throw gum at a kid on a scooter. So we see the scooter on the sidewalk going along. It's going much slower than the bus, and so we decide to throw something at the scooter. Now, again, yeah, if you knew what you were doing and you're trying to lead your pass, fine, so be it. But the bus is going 50 miles an hour and the scooter is doing 5. So you throw it at the scooter and all of a sudden totally like overthrow the scooter. And so now you've got this pattern showing up here. And so if you could go ahead and kindly draw in these, that would be awesome. And again, folks, this is just a way to remember the patterns of the air as it's moving. Alright, last but not least, person on the pole. This person here is upset with all these people throwing gum at each other, and he decides to get involved, and so he decides, well, the scooter's closest to me, so I'm going to throw it at the scooter. Scooter's doing 5 miles an hour, person standing still, person stands, throws the gum at the scooter, and totally misses the scooter, and so now you've got this situation occurring up here. And please make sure you draw all these. And let's label them. We have here, these are the trade winds. These are called the westerlies. And these are called the polar easterlies. There you go. If you could go and put this in your notes, I'd greatly appreciate it. Thank you very much. Pause the video. Sweet, all done. So we're back here and let's get out of this. We want to go and there we go. You'll note there from the last notes you took, you now have the northern hemisphere wind patterns all squared and memorized. Definitely go ahead and watch that YouTube video when you get a chance. And let's talk about the Coriolis effect. Alright, so because the Earth is spinning and the surface of the oceans basically have the Earth spinning underneath it, you get this kind of funky patterns occurring, and I'm just going to ask that you go ahead and note here the patterns of, say, like the North Atlantic, and you get this clockwise motion right here. Let's go and put this in the notes. And this is actually one of your vocabulary terms, the Coriolis effect. Nature of fluids, deflection of fluids against the surface of the Earth. You get this effect that we call it the Coriolis effect. And so it's different in the north and the south, but they basically mirror each other. And I'm just going to make the point or mention here that the North Atlantic moves in a clockwise pattern, while the South Atlantic moves in a counterclockwise. Note the Pacific, you've got a clockwise in the north and a counterclockwise down in the southern Pacific. And this is just how things roll. These are, you're going to find this in the north and the south just that way. And it also helps to explain why a lot of hurricanes swing along the equator line, and then it either goes right up our coast or right up right down the coasts of South America. You never see hurricanes going over to Europe. It just doesn't happen. And that's because of the Coriolis effect. Cool. Definitely pause the video so you can get this into your notes. This is, again, the Coriolis effect. There you go. Pause the video. Alright, done pausing. Alright, here we go. Now, let's see. We'll zip across this. We don't need to see this. We already talked about this. Alright. Nah, I'll hold off on this. Just know that in this last picture, this kind of helps to explain for those who have had my tree class, the Great Pacific Garbage Patch over here in the Pacific. Sorry here, apparently I decided to go and click on my screen and zip ahead on things here. That's a bit much. Just got a little excited, not gonna lie. It's this one here. The different global Pacific garbage patches are over here due to the spinning. Alright, so don't need to talk about the global conveyor belt, just know that in the day after tomorrow, that is basically a breaking of this conveyor belt, which is what caused the reintroduction of an ice age, but that would be pretty impressive, although there is some science that show that it is slowing down because of all the fresh water coming off of Greenland, but maybe something to watch down here in the YouTube channels. Alright, so Earth's energy budget. I'm going to talk about this and explain it, and you're going to use the C7 worksheets to really get a sense of it. Please start off by looking at this picture. Figure out what's going on with the sun, because it all starts with the sun. So you've got your incoming solar radiation. We're going to refer to this as either visible light or ultraviolet. And please note, right off the bat, you get some of it, well, I should point out this number, 340. 77.1 numbers are absorbed by the atmosphere. 77.0 is reflected by the clouds in the atmosphere, at which point total reflected solar radiation is 99.9 when you add these two right here. This obviously being reflected off of the ground or ice and snow. Remember albedo, it's important. And absorbed by the surface is 163.3. So if you take this number and this number, you should basically get this 340. So notice here, what is absorbed by the surface becomes thermal heat radiation, infrared if you will. And you're going to notice here that there's our number, the 398.2, and that's going to be coming back out of the Earth. Some of it is emitted out into space, absorbed by the atmosphere, emitted to the atmosphere, out to space. Some of it is re-emitted back down to Earth. Please note this number, 340. So 340.3 is emitted back down to Earth in the form of greenhouse gases. We do have some cooling that occurs overnight and so forth, but this is the Earth's energy budget explained in the C7 worksheet that helps to explain how the numbers work here on Earth with the energy coming in and the energy going out and the energy staying here on Earth. A nice simpler way to maybe look at it, 100% coming in, and you can see how things are reflected, how some is absorbed, how some is sent back out to heat, back out to space as heat, and how some of it is sent back to Earth, re-radiated due to greenhouse gases. There's no notes to be taken right now, just kind of trying to explain this so that when you're working on the worksheet you don't have a tough time with it. Alright, quickly, let's get through the greenhouse effect and be done. So, the solar budget really focuses on the numbers. The greenhouse effect just goes on the concept, what's happening. You've got, number one, you've got energy coming in from the sun. Some is sent back out to space, reflected off the atmosphere or off of clouds, but a lot of it does make its way through the Earth's atmosphere and hits our Earth's surface. Now, if it hits a very light-colored surface, portions of that are reflected back out to space, and if it's absorbed by, say, like land and ocean and concrete and so forth, it becomes a different type of energy. So you've got light here, and then it becomes infrared heat here. Thermal heat, if you will. Now, a way to think about that is some of that heat is lost to space. For those who remember those really hot days in the summer, if it's a clear sky, the Earth does a really good job of cooling down at night. We all look forward to the evenings when it finally cools. But if it's really, really cloudy out there, a lot of that heat is re-radiated back down to Earth. Now, that happens with the clouds, but it also happens with greenhouse gases. This is your carbon dioxide. This is your methane. A lot of that heat is re-radiated back down to Earth, keeping the Earth warmer. Now, the greenhouse effect is a necessity to life on Earth. Without it, the planet would be a snowball. However, things going on here in this region of our atmosphere, a thickening, if you will, of the greenhouse gases is causing more heat to be trapped and less to be radiated back out to space. So, greenhouse effect, think of being in a greenhouse. You can still let the light pass through. The light can pass through, no problem, but the heat is trapped in a greenhouse. Some comes out, but a lot is trapped. So, a nice way to view this, two sets of charts. The first one here has to do with temperature and carbon dioxide. You'll notice on the top here, you've got carbon dioxide going back 400,000 years. This is from an ice core called the Vostok ice core. And below that, you'll see temperature change, also going back 400,000 years. And for those who've watched videos with me before, you know that there is a connection between carbon dioxide and temperature going back 400,000 years. And it's rather interesting to see that these two literally peak to peak, peak to peak, peak to peak, valley to valley, valley to valley, valley to valley, line up so identical. What are we looking at? We're looking at evidence to really strongly suggest that as the planet's carbon dioxide goes up, so too does the temperature. As the planet's carbon dioxide goes down, so too does the temperature. To reinforce this, because some people say, oh, well, this is cyclic, no big deal, let's look in one more gas. Now we're looking at a chart that's got carbon dioxide, methane, CH4, and temperature. Look at this. Again, matching charts, matching graphs. As the planet's carbon dioxide and methane increase, so do the temperature on the Earth. So what we're looking at, folks, is just evidence to support climate change. There's plenty of evidence out there, and when I get back, we'll go over it a little bit more. But I would make the strong recommendation to keep it simple and just emphasize that, here, let's do it this way. Come on, you. All right. And I'd be putting this in my notes as CO2 and CH4, carbon dioxide, methane, increase, so too does the Earth's global temperature. Alright, there you go. That should be all I've got for you today. Go ahead and pause the video so you can get this little bit here, greenhouse effect and climate change. This is a very, very bare bones description of it. Light comes in, infrared is a combination of released and trapped. Nice. Alright, so what do we got here? I believe that's just about all I've got for you to talk about. And I would definitely go and watch, at least for sure, the first two videos here if you could, the first one. And then the second one there is quite humorous. The third one, if you get a chance, maybe. Alright, you guys, thanks a lot. You can pause the video now, and for tree period, tree is right over here. You've got the MCAS part number 3, and I'd like you to finish the island with Michael Bay. Alright, thank you very much.